in this part of the lecture, we're just going to talk for a few minutes um, about what we're doing, why it's so hard to get hydrogen, and what the current state of research and development is in getting cheaper, efficient ways to extract hydrogen from the world so that it can be safely used in fuel cells, because the technology itself is very, very promising. All right, so if we think of regular fuels like fossil fuels, that have been traditionally used to generate electricity in the form of a power plant. You might think of mining for coal, where you dig the fuel out of the ground, or drilling for oil, where you drill a hole into the ground until you hit the liquid petroleum, or drill until you hit a pocket of natural gas. So in this way, we'd be mining for fossil fuels. The thing is, we don't have reserves or deposits of hydrogen just existing in the Earth's crust or in the Earth's atmosphere, because hydrogen is so reactive. The element hydrogen is very, very reactive. There's a lot of it way out in the universe, but as far as here on Earth, it's mostly already been fixed into other compounds. So where are we going to get all the hydrogen we need? That's the big question. You can't dig it out of the ground. What we have to do is we have to chemically remove it from other compounds that it has combined with over time. And so one source is methane, which is the natural gas is methane. Natural gas is used now for heating and whatnot. And there's great natural gas infrastructure to move natural gas around from the place in which it is obtained from the ground to where it's used. So we have a lot of natural gas out there. And there is a way, by adding energy to natural gas and hot steam, to produce hydrogen. You can essentially reverse this reaction by the reaction that is normally used to produce methane from these two products by adding a lot of energy. Problem is, again, when you remove hydrogen from a hydrocarbon, no matter what, just like we saw in the case of the methanol, which was the liquid form, methane with an OH group is in liquid form, methane gas is a gas. Again, you're producing the problem carbon dioxide. So that's not a feasible solution if we're trying to figure out ways to generate electricity and not produce greenhouse gases. So you can do it, it's just not, it takes a lot of energy, so there's a cost right there, and you get carbon dioxide. Well, what about water? Water, 70% or something like that of the Earth's surface is covered with water. We've got tons of water out there. And what about using water as a source? Well, the problem with just using water is, again, the reaction, hydrogen plus oxygen to give water, gives off 286 kilojoules of heat per a mole of hydrogen. But at the same time, if you're going to go from water back up to produce hydrogen in obviously a very clean way, it's going to take the same amount of energy. So if this is your fuel cell reaction, and we're releasing 286 kilojoules of heat, if we want to just reverse that, it's going to take 286 kilojoules of energy to produce it. So just by that is a problem. If we try to get the hydrogen from the water, it seems like it's going to take as much energy that we would get back out of it. One way it is done, however, is electrolysis. And with electrolysis, this is where you use a battery and you separate the an anode and cathode in the battery, and this is the type of electrochemical cell here, which is called an electrolytic cell instead of a voltaic cell. Electrolytic. In this way, you force a non-spontaneous reaction to occur by pushing electricity through the reaction. So it's sort of the opposite of a galvanic cell or a voltaic cell. You're pushing the electricity and you're forcing a reaction that's non-spontaneous to occur. So in this way, you're forcing electricity. It's water plus electrical energy in the form of electricity to give the hydrogen plus the oxygen. Okay, so it's a way to do it. Right here we're producing hydrogen gas, and you can do this in your lab really, really easily. If your teacher's got a battery, you got a couple of pencils and some salt water, you can produce hydrogen right there on your lab desk. It's really easy to do. It's called the electrolysis of water or the hydrolysis of water, because lysis means break, and you're breaking the water into its elements. So it's easy enough to do. The problem is it takes energy. So, if it takes all this energy to produce the hydrogen that you're then going to turn around and use for energy, then it's kind of a moot point. Or that's one way to produce it, just with electricity. You can use heat energy to break this reaction. Electrical energy, it's pretty easy. You can use heat energy, but you have to raise the temperature to 5,000 degrees Celsius. So to get temperatures that high, you're going to have to burn a lot of fuel, which is going to produce a lot of waste and whatnot. So again, this is not a viable solution. This is not a viable solution. There are ways of doing it, getting hydrogen off the water, but it's not a viable solution. So that's as you can imagine, there's a lot of research right now going on to figure out cheaper ways to remove hydrogen from the water, such to produce a cheap and abundant source of hydrogen gas.